All right, I'm going to share my screen and we'll get started on notes. So we're going into 5E today. So we're still dealing with statistics stuff. Pretty much all of chapter 5 and chapter 6 is going to be dealing with some type of statistics. So 5E deals with what we call correlation and causality. So correlation and causality. So we'll start this off with some definitions on these. So we'll define correlation first. So a correlation exists between two variables when higher values of one variable consistently go with higher values of another variable, or when higher values of one variable consistently go with lower values of another variable. So let me write this out. So it exists between two variables when higher values of one variable consistently go with higher values of another variable So an example of that, I'm going to look at the price of a diamond versus the size of that diamond. So 1 carat diamond, let's just say, is $1,000. 2 carat diamond might be $2,500. So as the diamonds get larger in weight, the price of those diamonds is going to increase on average. So that's what they mean as one gets higher, the other value is also getting higher with it, okay? Or when higher values of one variable consistently go with lower values of another variable. So I could use something like COVID on an example of that. In one of my variables will be the number of people that get vaccinated. The other variable could be the percent of cases per 100,000 people. So as more people get vaccinated, I'm hoping that those cases of COVID actually would decrease over time. So that's an example where one's getting larger, but the other one is getting smaller, okay? So correlation tries to find relationships between the variables. Are they strongly related? If they are, then your graph will look more like a straight line. And it'll be going uphill if it's a positive correlation. That's when both variables go higher. A negative correlation is when the one variable gets larger, but the other one's getting smaller. So that would look like a line going downhill. So let's look at examples of correlations. And then I'll show y'all some graphs in a little bit. So there's a correlation between the variables height and weight for people. Right? The taller people tend to weigh more than the shorter people. Now, that's not always the case, but if you were to plot people according to their height and weight, you would notice overall that this would be a uphill type graph, which means there is a strong positive correlation. Okay, so that means taller people tend, so tend means they should to weigh more than shorter people. Okay, so if I was to make me a little graph of that and say this was the height and this was the weight, overall, when you started doing all your people, you would sort of notice that the graph would go uphill. Okay, so that's what I'm talking about, like a positive correlation. So when they both go up, it's a positive correlation. All righty. How about a correlation between the variables demand for apples and price of apples? So this would be sort of like a negative correlation, because as prices get higher on those apples, fewer people are going to want to buy those apples. So prices go up, the demand for the apples is going to decrease. Tendency, okay? Not always, but it's going to tend overall to go downhill. So graphs like that, down here you'd have your price of the apples. Over here would be the demand for the apples. And over time, when they're cheaper, more people are going to want to buy them. But you'll notice over time, overall, this graph is going to sort of want to go in a downhill slope. So that's what you call a negative correlation. So both of them show correlations, and it can be strong, either positive or negative. Now, if it's not a strong correlation, you'll see dots everywhere, and it won't really look like you're getting lines out of them, okay? So if y'all got that, I'm going to turn this. So also you would see correlations between things like practice time and skill. And that could be among piano players, which means those who practice more tend to be more skilled. And like we said, that's not 100%, but on average, if you took all your piano players, the ones that had more practice time probably in the long run had more skills. So something like that. Down here might be my practice time. Over here is my skill. And if they're not practicing much, they're going to be low. But the more they practice, you're hoping overall that this looks like an uphill type graph, okay? Now, sometimes you can have what we call an outlier, where you might have a general tendency going up, but then you might have that one dot that's way down here. In the future, we'll call those outliers, and they're just sort of not in with the normal, okay? So this player, this could have been a child prodigy. So had a tune, a ear for them tunes and stuff. So he might not have needed practice time to be good. But you always got to sort of watch the circumstances, okay? So those were examples of what we call a scatter plot. And that's just a plot in which each point represents the values of two variables. Okay, so my dots on this one up here meant practice time and skill. So you see where they are on your marks. And then, so if this was say 20 hours a week practice time, I would go up and then look left, and that would tell me how skilled they were. Okay, so that's what they talk about. It's representing the values of two variables, okay? So we'll look at relationships between two data variables. So those were the kind of plots I was showing y'all. So there can be, so this would be number one, no correlation. That means there's no apparent relationship between the two variables. So I've got dots everywhere. They're not forming a line for me. So since my dots are not really forming a line that I can tell something's going up or down over time, there would be no correlation. So I can't say, hey, is this one's increasing? This one's either increasing or decreasing. We can't make that call, okay? Second, I've sort of showed you would be positive correlation. So both variables tend to increase or decrease together. So both variables tend to increase or decrease together. So they're either both going uphill or they're both decreasing. It's not when I got one increasing and the other decreasing. They're both doing the same thing. So someone might have made their graph in a different, instead of going from small diamond to big diamond, they might have started with the large diamonds and went to the small diamonds. Well, if you start with large diamonds and go to small diamonds, then those prices would decrease as the sizes were decreasing. So they're both doing the same thing together, okay? They're either both going up or they're both going down. That's what you call positive correlation. So a negative correlation one variable increases while the other variable decreases. So one variable increases while the other variable decreases. And it don't matter which one, but one's going to get larger while the other one sort of gets smaller. So they're going to sort of have a tendency of making your lines, like I said, look like they're going downhill from left to right instead of uphill. Okay. And then y'all, the other thing, the strength of a correlation. The more closely two variables follow the general trend, the stronger the correlation. So if you can definitely tell you got a line going uphill or a line going downhill, and most of your points are sort of following those line tendencies, then you got a strong correlation. So a perfect correlation would be all points would lie in a straight line, okay? So a poor correlation, your points are scattered all about, and it's hard to really tell if you got one going up and the other one going up, or is one going up and one going down. You really can't tell what's going to happen, okay? So that'd be a weak one. So I'm going to share my screen and I'm going to show you some pictures of a positive correlation and a negative correlation. So let me go to the page. So y'all, this is a positive correlation, and it's the one talking about the diamonds. I got the weight in carats, and then on the vertical scale is the price in dollars. So, and these were a lot of different 1 carat diamonds, and they ranged from anywhere from, looks like a little over 4,000. A lot of them right in here between 6 and 8. And then I had one sort of way up here on its own at 10,000. But if you notice, as my diamond sizes get larger, 1.5 to 2, you can almost see that this is definitely going in an uphill type pattern. And then this one way up here on the top, it would probably be an outlier because it's so much higher than the others. But y'all, just wanted y'all to notice the general tendency is just wanting to go sort of uphill, which would give me a positive correlation. As the diamond weights get larger, the price in dollars is going to also get larger. So let's look at negative correlation. So this one, we got life expectancy on the bottom axis and infant mortality, deaths per 1,000 births, okay? So over here, as life expectancy gets larger in years, going from, say, looks like the smallest point was about 50-something years. My largest point is almost at 80 years. But notice, overall, these points tend to go in a downhill type line. So this one might not be what we would call a real strong correlation, because you do got points sort of scattered here and there. But overall, we got a downhill trend, okay? So that's just showing that the higher life expectancy generally goes with a lower infant mortality. All right, and y'all, just a couple more I wanted to show you. So this was doing 2 weeks of data comparing the actual high temperature for today with the same day forecast. That's on the left. And then on the right, it's the 3-day forecast and the actual temperature. So if you notice, they both sort of show a trend. That first one, it's almost got a defined line going through there, other than, like I said, you got one real high point here that would almost be what we call an outlier. And that happened on the both of them, on the 3-day forecast and the same day forecast. Also, the 3-day forecast generally has that straight line going uphill. But I would think it's a little weaker than the first one, because you do not have as much of a defined line as you did on that first one. So the left one would have what we call a stronger correlation than the one on the right. Which means basically, if you want a more accurate weather forecast, you're going to go with your same day forecast versus your 3-day forecast. They're still positive, but they're not as accurate as that same day, okay? All right, y'all, so I'm going to go back to the pad, and I just want to sort of show you a few of the homework problems you might see in this section. So let me go to a pad. All right, so I'm going to turn this page, y'all. So how about homework? Examples. So I'm just going to go through a few of these so y'all sort of know what to expect in these pages. So first thing they want us to do is to define positive correlation. Y'all, let me give y'all 4 answers and y'all sort of tell me what y'all think a positive correlation is. So A, positive correlation means that there is a good relation between the 2 variables. B, positive correlation means that both variables tend to increase or decrease together. C, positive correlation means that 2 variables tend to change in opposite directions, with one increasing while the other decreases. And D, Positive correlation means that there is no apparent relationship between the two variables.
Answer is B.
So which one?
B.
B, that's it, man, because it means that they both tend to increase or decrease together. So good job. So both variables tend to increase or decrease together. So number two then would be, what is negative correlation? So 4 choices. A, negative correlation means that there is no apparent relationship between the two variables. B says negative correlation means that there is a bad relationship between the two variables. C, negative correlation means that both variables tend to increase or decrease together. D, negative correlation means that two variables tend to change in opposite directions, with one increasing while the other decreases.
D.
Oh, say that a little loud.
D.
D, delta.
Mm-hmm.
That's it. I was trying to listen to you while I was looking for that chat, and that chat's being quiet today. But that means that the two variables change in opposite directions. Right, with one increasing while the other decreases. So how about this one? No correlation. So no correlation. A, no correlation means that both variables tend to increase or decrease together. Well, y'all done use that for number 1. No correlation means that there is no apparent relationship between two variables. C, no correlation means that the two variables tend to change in opposite directions, with one increasing while the other decreases. Well, we use that one on number 2. And D, no correlation means that the two variables are always 0.
No apparent relationship.
Yeah, so that was actually B. No
Yeah.
correlationship means that there is no apparent relationship between the two variables. But I might be looking at the weight of kids versus the color of their hair. And as my weights increase, I might have no relationship showing me that they're having more brown-haired kids versus more blonde-haired kids versus more red-haired kids versus more black-haired kids. I wouldn't be able to find a relationship. So something like that we would call a no correlation. So how do we determine the strength of a correlation? Well, that should be TH, my bad. How do we determine the strength of a correlation? So the way we determine the strength of a correlation, the more closely the two variables follow the general trend. That means the stronger the correlation. And remember, that could be a positive or negative. Positive correlation just means they both increasing. It don't mean it's stronger than a negative correlation. Because as one's getting larger, the other one might be getting smaller. What determines that strength is how close are they to making that line down through there, okay? If they're really close to the line that looks like it's going either uphill or downhill, then it's stronger. If they're more scattered, then that's going to sort of make them weak. So see if this makes sense. There is a strong negative correlation between the price of tickets and the number of tickets sold. So what they're saying, price of tickets and the number sold. They're saying that there is a strong negative correlation. So that means it's strong and it's sort of going downhill for us, okay? And we don't know where them dots are placed, but it's a strong negative, so it's going downhill. So this suggests that in order to sell a lot of tickets, the price should be lowered. So does that make sense? If the price goes up, the number of tickets I'm selling is going down. So would it make sense that if they lowered the prices, the number of tickets would be more sold? Well, that's probably going to make sense, because if you notice over here where the prices were higher, they did sell more tickets. So yes, we would say something like that made sense, because we can show that it actually did, for the lower prices, sell more tickets, okay? All righty, y'all. So that's most of the 5E. Now, I'm not doing all the homework, so some of them I just wanted y'all to sort of think on and see what y'all would come up with on them. I just wanted to make sure y'all really understood what positive and negative and no correlation were, and how to visualize those scatter plots, okay? So y'all, let's see, next class we'll start in 6A. So the next class will be probably longer than today, because I'll do some of that support for 6A, and then I'll knock out the 6A lecture. So let's see. I'm going to stop that share. So y'all have questions on this?
No.
So play with your 5E tonight. They're not too bad. It's just doing questions like I was showing you. Some of those where they want you to think. They'll show you a few scatter plots and see what y'all think about the strength and the weakness of those correlations. So y'all do that, and like I said, next class we'll do 6A and the 6A MR. All right, remember, if you haven't gotten me that project yet, I need to get those. So it looks like most of y'all on here have sent me y'all, I think. So I'll start trying to grade those, and I'll make a post on those grades. All right, so nothing bugging y'all. Oh, I'm not seeing no chats or anything, so let me stop the recording.